All right, let's start off here on number one. So these ones, we're going to put them in the correct category. So I would kind of start off here with not a polynomial. And so for these ones, what we're looking for is negative or fraction exponents. And so I see right off the bat that this one I'm going to put right there because it has that negative exponent. And then actually I'm also going to put this one because we know that that is really x to the negative third. It just got dropped to the bottom. And so then I'm going to say that one is a negative exponent as well. So then after that, all of these have positive exponents. This one's really a 1 right there. And so then I'm just going to sort them into the other categories. So a quick note, though, even though this one has a fraction, it's not in the exponent. That's really the key there. And although this one's negative, it's not in the exponent. So if the negative or fraction is in the coefficient, that's fine. All right, so now we'll sort these out. So then this one has 1, 2 terms, so I'm going to put that there. And then f also has 1, 2 terms, so I'm going to put that there as well. And then the 3 terms is right here, so that's going to go there. And then the monomial has 1 term, so that's going to go there. All right, this one they want to simplify and write in standard form. So to simplify, we're going to distribute this. So it's going to be 4x plus 8. And on this one, we're going to distribute a negative 5x. So that's going to become negative 5x squared. And then minus 35x. And we'll go ahead and combine like terms here. So it looks like I only have one x squared, so I'm just going to keep that the same. We'll combine 4x and negative 35x makes negative 31x. And then we have the plus 8 just out back. All right, next up, we're going to multiply these two together. You can use FOIL for this, first, outer, inner, last, or you can do the box. So I'll go ahead and do the box here, 2r plus 8, and then negative 4r plus 6. So we're just going to multiply the big numbers, but then add the exponents. Multiply the big numbers, and then add the exponents, and then multiply the big numbers and add the exponents, and then multiply the big numbers, and then there are no exponents. Okay, so next up we'll just combine like terms here. So we get negative 8r squared, and then we'll combine those two to make negative 20r, and then the plus 48 has nothing to combine with. All right, next up we want to multiply this one. So I'm going to draw the box again. So you get 3x minus 6, and then 3x minus 6 again. So whenever it's squared, we always want to write that one twice instead of the squared. So same idea, you got 9x squared, negative 18x, and then positive 36. Then we'll just combine the like terms in the middle here. So we get 9x squared minus 36x plus 36. All right, one more, or another multiplication here. So we get 8n plus 4, and then 8n minus 4. So then you get 64n squared, 32n, negative 32n, and then negative 16. Now in this case, the like terms actually cancel out, so we get 64n squared minus 16. All right, these ones are multiplying a 3 by 2, so we'll do a 3 by 2 box. So we got 4x minus 5 over here, and then 5x squared plus 5x minus 2. So we'll multiply the big numbers and then add the exponents in every spot. And that would be negative 25x, and then positive 10. All right, so we see that our like terms line up diagonally again, like usual. So we get 20x to the third, and then minus 5x squared, minus, that would be 33x, and then plus 10. And that's it. All right, this one we want to subtract, and so that's going to be, they're not going to use a box for this because this is not multiplying. Multiplying is only for the box. So instead, we're just going to distribute this negative in here. It's going to change all the signs. So it'll make it negative 4p squared plus 4p to the fourth plus 5p. And so then I'm going to rewrite this one just the same way. Okay, and now we're going to combine like terms. So I got 8p to the fourth and then 4p to the fourth. So that's going to make 12p to the fourth. And then we have, let's see, negative 5p squared and negative 4p squared makes negative 9p squared. And then 6p and 5p gives me 11p. All right, next up here, we are going to actually when it's a plus here, it's still no box, but it's actually even easier. We just have to combine like terms, so we don't have to change anything. So I'm just going to jump right into that. So we have 8 minus 4 would give you 4x to the fourth. And then for my x squareds, I got positive 1 and then positive 3 makes positive 4x squared. And my numbers, I got plus 6 and plus 1 gives you plus 7. All right, next up here, this one is multiply. I'm going to go ahead and distribute. You could use a 3 by 1 box, but I'm just going to distribute, so you get 6m to the third. So I multiply the big numbers and add the exponents, and then you get 12m to the second, and then 24m. So just multiply everything. But that means for exponents, add the exponents. All right, next up, number 10, we want to factor completely. So I want to do a GCF on this one. Always check GCF first. So I see that these can both divide by 7, and then the smallest exponent is m to the fifth. And then I'm going to open up a parentheses, and then we're going to divide the big numbers. So this is going to become 4, and then I subtract the exponents, so that'll be 4. So I kind of think of it like I had 9 m's in there, but I took 5 out, so I have 4 left over. So then 35 divided by 7 is 5, and then no m's there since I took all 5 out. I look inside, there's nothing I can do there, so I am done. All right, next up here we have 4 terms, so we always use our factoring by grouping with 4 terms. And so I see the first group, I can take a 2 out and an x squared, so both those numbers divide by 2, and then the smallest exponent is squared. If I do that, that's going to leave 6x and then minus 1 there. It's minus 1 because 2 divided by 2 is 1, and then I took all the x's out. The second group, I can take out a 6, and that leaves me with 6x minus 1. Oh, no, it's not. I can only take out a 5, and that'll leave me with 6x minus 1. So I'm thinking about what number these both divide by, so they both divide by 5. So I take that out front. Okay, so whenever this works, you get the same thing in both parentheses, 6x minus 1, that's one of them. And then the other parentheses is for the stuff outside, so it's 2x squared plus 5. All right, next up, this one, I see that there's no GCF, and so I'm just going to go into my x. So I'm trying to multiply to 12 and add to 7. Once again, I get that from this is a times c, and that's b. So what multiplies to make 12? Well, I know it's 1 and 12, 2 and 6, and 3 and 4. So it looks like 3 and 4 is going to work. I have an a value of 1, and so that means I don't need a box here. I don't need that extra step. I can just say r plus 3, r plus 4, and just be done with it. All right, next up, factor completely. So this one I do see a GCF. I think it's 2, so I'm going to take the 2 out front. And so I divide everything by 2, and that'll give me 6x squared plus 8x minus 14. However, I see that these are all still even, so I'm going to GCF another 2. So I did that on the first step, now I'm going to do it again. So then out front is 2 times 2, and that'll leave me 3x squared plus 4x minus 7. So that's good here. So now I'm just going to leave this 4 out front here, which is the 2 times 2. And now I'm going to work on the inside. So I need to do the x here. So I do a times c, which is negative 21, and then b is 4. So that sounds like it's going to be 7 and 3 if I make the 3 negative. And so then what I do here, if you can use the box or the grouping technique. So the grouping technique will be 3x squared, and then this one you split up as negative 3x and then as 7x, and that's coming from here. You can switch the order on that, it really doesn't matter, and then you put the negative 7 out there. So the thing you have to be careful about on this one, just make sure that this 4x splits up like that according to this over here. So then I would use the grouping technique on this. So I'm going to group these two together. I can take out a 3x, not 3x squared, just 3x, and that leaves me with x minus 1. And then on this group I can take out a plus 7, and that leaves me with x minus 1. So then I can write this as 3x plus 7 times x minus 1, with that 4 just staying out front. Instead of this, you could have used the box, the inside out box, to get those as well. All right, next step here, factor completely. So this one, I see no GCF. You can't do 2 because they're not all even. So I am going to have to just use the x here. So a times c would be 25 times 16. So I'm going to have to do that here. So that'd be 150, 0, 225. Okay, so that'd be 400. So we got 400, and then multiplying to 400, adding to 40, which is b. So actually pretty easy. It's 20 and 20. But I do need the grouping or the box here. So I'll go ahead and use the grouping again. But once again, you can use the box instead. So if I use the grouping, I would put 25x squared right there. I would put 16 out there. And then these guys go here and here with an x. and that really makes that middle term of 40x. And then we'll group it together. And remember what I said, or you can use the box here, inside out again. And so the first group I can take out 5x, and that leaves me with 5x plus 4. The second group I can take out a 4, and that'll leave me with 5x plus 4. So this ends up being 5x plus 4 times 5x plus 4. And then very often they'll just write that as 5x plus 4 squared, which means multiply it by itself. All right, next up, number 16. So this one wants us to factor. There's no GCF here, but I do see it's 2 terms. And so I think it's the difference of perfect squares. I know that 64 and 81 are perfect squares, and they are subtracting. So whenever this happens, we kind of just square root the whole thing. And this becomes 8n and 9 on both of them, because the square root of 64 is 8, square root of n squared is n, and then 81 square root is 9. And then it's always 1 plus and 1 minus on these. All right, next up here, I'm going to factor. So we're going to think of 2 numbers that multiply to 42 and add to -7. And this is a times c up there, and that's b. We don't need the box here or the grouping because we have no a value, or the a value is 1. And so I'm going to think about what multiplies make 42. Obviously 1 and 42, 2 and 21, 3 and something. Let me check that out. 4, so 14, so 3 times 14. All right, what else do we have? 4 does not work, 5 no, 6 I believe would work. Yes, 6 times 7, and that's it. But I can see that none of these are going to make 7. So what that means is this is not factorable. And sometimes they call that prime. All right, next up, some more factoring here. So I want to do GCF first. So I'm going to take out a 2. That gives me 6n squared plus n minus 40. So now I need to do the inside here. So I got my a, b, and c. And so my a times c is going to be negative 240. And then my b is 1. So shoot, this is a tricky one here. Let's think about what makes 240. So the first thing I'm thinking is 10 and 24. That's not going to work. What would, let's see. What's 240 divided by 12? I feel like that's it. Oh, that would be 20. So 12 times 20. So that doesn't work either. But I feel like I'm getting closer here. The numbers are getting closer together. So I'm going to go ahead and try a 15. That might work. I'm not sure if it's even divisible, so let's check it out. So this would be a 90. And then 15 goes into 90. Let's see, that would be 6 times. So we get 15 times 16. So that does work. So I got 16 and negative 15. Now I can use the grouping for this, or I'll use the box on this one. So the inside out box, you put 6n squared, you put negative 40, and then these guys go here and here with an n. And then I do the GCF going this way, and so that's going to be 3n. GCF going that way would be 8. And then GCF going this way would be 2n. And then GCF going this way would be negative 5. I just kind of double check here, make sure everything multiplies back in. Yep, that's good. That's good. Oh, that's negative 15n and negative 40. That's all good. So then we have the 2 we took out front, and we get 3n plus 8, and then 2n minus 5. So I use the box on this one, but once again, you can use that grouping technique that I've been using on previous ones as well. All right, last one here. We'll do some grouping on this one. So I group those together. I see the first group I can take out x squared, and that leaves me with 3x plus 1. The second group I take out, I would take out a negative 25. I don't know why I did that in red. Let's do it in blue. Minus 25. That will leave me with 3x plus 1 as well. So then I can group this together, x squared minus 25, and then 3x plus 1. But I see that this one is the difference of perfect squares. And so I can break that apart more into x plus 5, x minus 5. and just keep that 3x plus 1.